Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, I am Luqman Hakim Mohammad Yusoff, 1715465. I want to present about my final year project 2 about application of struct and tie method in designing encourage block. Okay, first thing first, what is the struct and tie? Struct and tie is a method for dealing with D regions in the reinforcement concrete. Reinforcement concrete can be defined into two categories, which is first is B region and second is D region. Okay, the B region is the concrete follow the witness stress block concept where based on Bernoulli's principle or hypothesis of linear strain distribution where plane remain precision before and after remain plane. And the D region is the bending member do not embrace the concept. Usually happen at the region nearby support and concentrated load. Okay, the problem statement of this final year project is first, we must predict the flow of internal forces calculated carefully. Then the design must follow guidelines either in Eurocode 2, AS2, LRFD or SCI 318. Okay, the proposed size and quantity of strut and tie members must be adequate to resist the force, plus must be fit in the design anchorage block. Okay, our objective for this final project is to encounter the problems stated in the problem statement section. Objective of these projects are to design the anchorage block and simulating by using the strut tie software. Second, to estimate the maximum load for each design block. And third one is to propose a table of amount of reinforcement needed in the anchorage block. Okay, the research gap of this FYP is first, analyzing the anchorage block by using strut and tie method. Know how to construct a stress flow by using a truss analogy. The previous researcher focused on pile caps, deep beams and frames only. So we try to initiate a new structure member, critical structural member, which is at anchorage zone or block. Okay, this is the diagram illustrate the strut and tie method that have been used in designing the deep beam. This one is an location of B regions and D regions at portal frame. And the last one is in designing the pile cap. So now we focus on the anchorage zone or anchorage block, which is as illustrated here. Okay, we have two categories. For this study, we try two cases, which is first is single centered anchorage, and second one is two symmetrically placed anchorage. Okay, the formula have been used as stated as shown that we extract from the Eurocode 2. Okay, this is the Gantt chart flow for the whole process, the FYP2. First, we design the, I want to enlarge. First, we discussing with, I was discussed with my supervisor. Then the second process is survey the typical anchorage block size. Then the third process is preparation of the software, which is trial mode, and fourth, getting the result, and fifth, manual calculation by using Excel. That by using formula we got from the Eurocode, discussing the finding, and lastly is preparation of report. Okay, the methodology of the final year project is first we survey the typical available type of pre-stressed concrete beam. The second one is list out all the formula stated in the standard guideline. For this study, I focus on Eurocode 2, design of concrete structure to calculate the stress distribution on pre-stressed reinforcement concrete beam at a gauge zone. Then the last one is I try simulating in the extract software. Okay, typical of stress beam, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I focus on 9 because there is so many types in the upper market. But in this study, I focus on SY beam and I beam only because usually have been used in the construction site. Okay, the span range, the longest one is these two types, SY beam and I beam. Okay, these are the detail of the SY beam have been run in my study. This is also the detail of the I beam. Okay, if you notice that the value of FRBU is for FYP is same and the I beam is different. Okay, the I beam after going through the catalog of pre-stressing stress, which is SY beam and I beam, there is 6 different sizes of each type. To make the data presentation more organized and easy to understand, the size of steel plate I use fixed 200 by 200 for all sizes, and the force from the cable is fixed 2000 kilonewton except for I-beam section, which is section 1 and section 2. I fix on 1500 kilonewton. Okay, as shown is the table, as shown in this table. This one and this one and this one. Then after that, these are the how we get the this design distribution force by using this formula. ACO is a steel plate, while the AC1 is the area on the anchorage. This method, if we have more than one anchorage, one steel plate, we must consider the area of ACI do not overlap of each other ACI. Okay, for example, one steel plate can produce one ACI. If two plates produce two ACI, which is don't overlap with each other. Okay, the view of anchorage for the first case, single central point load, and second one is two symmetrical point load. Okay, the rectangle, the bigger rectangle is represent the ACI, which is this one ACI have, but I don't show because you know they do not overlap each other. This one is overlap each other. Okay, what finding I have got in this study is okay, the anchorage block tends to split either in Y direction or Z direction. After going some the calculation and simulation by using extract style software, the bursting force tend to burst or split into two parts, either in Z direction, horizontally straight, or Y direction, vertically straight, as shown in this figure. For both cases, for single concentrated point load or two symmetrically point load, the bursting force and moment as shown in this table. Okay, this is single point load for SY beam, I beam. The forces of two symmetrical point load, SY beam and I beam. If you notice, for single cases, SY beam and I beam, the forces tend to split in vertical plane. Vertical plane, I mean, is this one, this one. Okay, this one vertically. if the two cases, we can see the force is bigger on the horizontal plane. So it tends to flip horizontally, which is Z direction, like this one. Direction, this one. Okay, this one. We compare which bursting force in web, bursting force is in flange. Okay, the proposed amount of link for both cases is stated in below. Okay, if you can see, if a two symmetrical point load, we have bigger compared to single concentrated load. But the value we uh, try, we got from the horizontal plane for two symmetrical point load, and single point load we obtain from the vertical plane. Okay, the stresses flow. Okay, okay, the result flow result for okay, this is the real construction reinforcement link for the anchorage zone, which is you can see on the top and the bottom. There is so many cables here, but we focus on two cases to see the pattern of the bursting force. Okay. Okay, after running the process, the stress flow tends to become like this. This is for two point load cases for I1, I2, I beam 2, section 2, I beam section 3, and so on. SY, okay. The SY1 until SY6 is fixed 233.3 as shown in the table. Okay, for the link to sustain the bursting force is this anchorage link, links, and we can use also the shear links that usually we design in the conventional design of beam. But the value after the value of required reinforcement are obtained by using the formula stated in the Eurocode 2, the engineer must provide sufficient area of reinforcement so that anchorage block did not split either horizontally or vertically. In design stage, there is no specific number of bars should be placed in the concrete structure. It's because it depending on the preference of assigned engineers based on design standard verified by local authority. Okay. The actually this suggested number of bar, but the number of bar can be reduced or increased because of the using of size of the rebar suggested by the uh, assigned engineer on the site. So I cannot fix the number of bar because it's depending on the creativity of assigned engineer. Okay, in the summary, the summary for this study is uh, the possibility of crack of the anchorage zone after being applied force from the post tension cable. After done the simulation of on two cases, we can predict what and where crack might happen after a certain period depending on the arrangement of the post tension cables. For this study, a single concentrated point load tend to have crack along the middle of the height of the beam, while two symmetrical point load tend to have crack along the middle of wide beam, width beam. Therefore, we can conclude that if the cable are arranged more likely at the center of vertical axis of the anchorage view, the split will have a perpendicular direction of the axis and of the axis, and vice versa cases. Okay. Reinforcement links must consider the bigger forces in the Z or Y plane The amount of reinforcement link also need to be decided by appointed engineers. We just provide some area of reinforcement for the case study only. The force the force from the force section cables also just assume, because in real life project, the procedure to determine the force from the cable is quite tedious. So conclusion is all the objectives are achieved. Then the second one is strut and tie method was applied on the anchorage block and zones to estimate the stress flow and how the bursting force might happen. So, and the last one is we can conclude that the strut and tie method is quite an easy method to design a good quality of anchorage. So that's all from me. Thank you.